ಹಲೋ ಮೈ ಡಿಯರ್ ಫ್ರೆಂಡ್ಸ್, ಎಲ್ರಿಗೂ ನಮಸ್ಕಾರ. ಮೈ ಸೆಲ್ಫ್ ಕೋಡಮ್ ನವೀನ್ ಕುಮಾರ್. I welcome back you all to this incredible platform Physics Wala. Now, in our Abhiyan Kannada batch last class, what we have studied ಏನು ಕಲಿತಿದ್ದೀವಿ? thermodynamics, right? thermodynamics chapter ನು ಮುಗಿತು. ಈ ಕೆಮಿಸ್ಟ್ರಿದಲ್ಲಿ ನೆಕ್ಸ್ಟ್ ಇನ್ ಅವರ್ ಫಸ್ಟ್ PUC and the important chapter. Now, ಯಾವ ಚಾಪ್ಟರ್ ಅದು? ಈಕ್ವಿಲಿಬ್ರಿಯಂ. Now, that is equilibrium. Now, JEE mains ಮತ್ತೆ NEET ಮತ್ತೆ and KCET. The damn sure question will be from this chapter. Either it may be from the chemical equilibrium or it may be from the ionic equilibrium. Today in this equilibrium, equilibrium ಅಲ್ಲಿ ಇವಾಗ now what we are going to see, that is chemical equilibrium. Chemical equilibrium I am going to start now. Let's start our chapter now. Before starting, start ಮಾಡೋಕೆ ಮುಂಚೆ ಲಾಸ್ಟ್ ಚಾಪ್ಟರ್ ವಾಟ್ ವಿ ಹ್ಯಾವ್ ಸ್ಟಡಿಡ್, ಯಾವ ಚಾಪ್ಟರ್ ಕಲ್ತಿದ್ವಿ ನಾವು? ಥರ್ಮೋಡೈನಮಿಕ್ಸ್, ರೈಟ್? ನಾವು ಒಂದ್ಸಾರಿ ರೀಕ್ಯಾಪ್ ಮಾಡೋಣ. ಲಾಸ್ಟ್ ಚಾಪ್ಟರ್ ವಾಟ್ ವಿ ಹ್ಯಾವ್ ಸ್ಟಡಿಡ್ ನಾವು, ದಟ್ ಈಸ್ thermodynamics, right? Thermodynamics. Now, thermodynamics ಅಲ್ಲಿ what we have studied? Thermodynamics ಅಲ್ಲಿ what we have studied? Now, system, surrounding, ಮತ್ತೆ boundary. Now, system, surrounding, boundary. Next, open system, closed system, isolated system. Next, state function, path function. Now, next, extensive property, intensive property. Next, first law of thermodynamics. First law of thermodynamics formula ಏನು? Now, change in internal energy is equal to Q plus W ಅಲ್ಲ? Q plus W. Next, thermochemistry. Next, entropy. Next, Gibbs free energy. Okay. Now if anyone miss the chapter, if you have missed the chapter thermodynamics, ನಾವು ಪ್ಲೇಲಿಸ್ಟ್ ಅಲ್ಲಿ ಇರುತ್ತೆ ಚಾಪ್ಟರ್, ಅಲ್ಲಿ ಹೋಗಿ ನೋಡ್ಬೋದು. ಓಕೆ, ಈಸಿ ಕ್ಲಿಯರ್? ನಾವು ಲಾಸ್ಟ್ ಕ್ಲಾಸ್ ಅಲ್ಲಿ ಥರ್ಮೋಡೈನಮಿಕ್ಸ್ ಮುಗಿದಿದಲ್ಲ. ನಾವು ಟುಡೇ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಸ್ಟಾರ್ಟ್ ಯಾವ ಚಾಪ್ಟರ್? ಕೆಮಿಕಲ್ ಈಕ್ವಿಲಿಬ್ರಿಯಂ. ನಾವು ಇವತ್ತು ಈ ಕೆಮಿಕಲ್ ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಅಲ್ಲಿ ನಾವು ವಾಟ್ ಆರ್ ದ ಕಾನ್ಸೆಪ್ಟ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಕವರ್. ನಾವು ಯಾವುದು ಕಾನ್ಸೆಪ್ಟ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಕವರ್ ಅಂತ ಒಂದ್ಸರಿ ನೋಡೋಣ. ನಾವು ಫಸ್ಟ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಸಿ what is the basic definition of the equilibrium. Equilibrium andre ಏನು we are going to see. Next we are going to see physical equilibrium ಮತ್ತೆ chemical equilibrium. Physical equilibrium ಮತ್ತೆ chemical equilibrium. Okay. ನಾವು ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಅಂದರೆ ಏನು, ಮತ್ತೆ ಫಿಸಿಕಲ್ ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಅಂದರೆ ಏನು, ಕೆಮಿಕಲ್ ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಅಂದರೆ ಏನು, ನೆಕ್ಸ್ಟ್ ಲಾ ಆಫ್ ಮಾಸ್ ಆಕ್ಷನ್, ಅಂಡ್ ರಿಲೇಶನ್ಶಿಪ್ ಬಿಟ್ವೀನ್ KP and KC. ರಿಲೇಶನ್ಶಿಪ್ ಬಿಟ್ವೀನ್ KP and the KC. ನಾವು ಇವತ್ತು ಈ ವಿಡಿಯೋದಲ್ಲಿ ನಾವು ಈ ಕಾನ್ಸೆಪ್ಟ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಸಿ. ದೀಸ್ ಆರ್ ದ ಕಾನ್ಸೆಪ್ಟ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಸಿ. ನೆಕ್ಸ್ಟ್, ಇಂಟ್ರಡಕ್ಷನ್. ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಅಂದ್ರೆ ಏನು? ಈಕ್ವಿಲಿಬ್ರಿಯಂ, ದಿ ಸ್ಟೇಟ್ ಆಫ್ ದ ಸಿಸ್ಟಮ್ ಎಟ್ ವಿಚ್ ಪ್ರೆಷರ್, ವ್ಯಾಲ್ಯೂಮ್, ಟೆಂಪರೇಚರ್ and compositions have fixed value and does not change with the time. ಇದರಲ್ಲಿ ನೋಡಿ, ನಾವು ಈಗ ಒಂದು ವೆಸಲ್ ತಗೊಂಡಿದ್ದೆ ಅಂದರೆ ನಾವು ದಿಸ್ ವೆಸಲ್ ಈಸ್ ಫಿಲ್ಲಿಂಗ್ ವಿತ್ ವಾಟರ್. Now this vessel is filling with the water. Now E vessel, it is filling with the water with 5 km per hour. Now ಈಗ ಈ ವೆಸಿಲ್ ಇಟ್ ಈಸ್ ಫಿಲ್ಲಿಂಗ್ ವಿತ್ ದ ವಾಟರ್ ವಿತ್ 5 km per hour ಅಲ್ಲ. ನಾವು ಏನಾಗುತ್ತೆ, ನಾವು ವಾಟರ್ ಲೆವೆಲ್ ಇಂಕ್ರೀಸ್ ಆಗುತ್ತಲ್ಲ. ನೆಕ್ಸ್ಟ್ ನಾವು ಇಫ್ ಐ ಮೇಕ್ ಇಲ್ಲಿ ಹೋಲ್ ಮಾಡಿದ್ದೇನೆಂದ್ರೆ ಏನಾಗುತ್ತೆ, ವಾಟರ್ ಹೊರಗಡೆ ಹೋಗುತ್ತಲ್ಲ ವಾಟರ್. ನಾವು ಲೆಟ್ ಅಸ್ಯೂಮ್ ವಾಟರ್ ಈಸ್ ಗೋಯಿಂಗ್ ವಿತ್ ದ 2 km per hour. 2 km per hour ಅಂದರೆ ಇಲ್ಲಿಂದ ವಾಟರ್ 5 km per hour ಬರ್ತಾ ಇದೆ. ನಾವು ಇಲ್ಲಿಂದ ವಾಟರ್ 2 km per hour ಹೊರಗಡೆ ಹೋಗ್ತಾ ಇದೆ. ಏನಾಗುತ್ತೆ, ವಾಟರ್ ಲೆವೆಲ್ ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತಾ ಕಡಿಮೆ ಆಗುತ್ತಾ? ಏನಾಗುತ್ತೆ, ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತಲ್ಲ. ಯಾಕಂದ್ರೆ ವಾಟರ್ ಈಸ್ ಕಮಿಂಗ್ ವಿತ್ ದ 5 km per hour. ನೆಕ್ಸ್ಟ್ ಈಗ ನಾನು ಒಂದು ಬಿಗ್ ಹೋಲ್ ಮಾಡಿದ್ದೀನಿ. ಏನಾಗುತ್ತೆ, ನಾವು ದಿಸ್ ಟೈಮ್ ವಾಟರ್ ಈಸ್ ಗೋಯಿಂಗ್ ವಿತ್ ದ 3 km per hour. ವಾಟರ್ 5 km per hour ಬರ್ತಾ ಇದೆ. ನಾವು 3 km per hour ವಾಟರ್ ಹೊರಗಡೆ ಹೋಗ್ತಾ ಇದೆ. ಏನಾಗುತ್ತೆ, ಮತ್ತೆ ವಾಟರ್ ಲೆವೆಲ್ನು ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತೆ. ಯಾಕಂದ್ರೆ ಇಲ್ಲಿಂದ 5 km per hour ವಾಟರ್ ಬರ್ತಾ ಇದೆ. ನೆಕ್ಸ್ಟ್ ಇನ್ನೊಂದು ಬಿಗ್ ಹೋಲ್ ಮಾಡಿದ್ರೆ ಅಂದ್ರೆ ನಾವು ಏನಾಗುತ್ತೆ, ನಾವು ಈಗ ವಾಟರ್ ಈಸ್ ಆಲ್ಸೋ ಗೋಯಿಂಗ್ ವಿತ್ ದ 5 km per hour. ನಾವು ಇದರಲ್ಲಿ ವಾಟರ್ ಈಸ್ ಗೋಯಿಂಗ್ ವಿತ್ ದ 5 km per hour. ನಾವು ಏನಾಗುತ್ತೆ, ಈಗ ಏನಾಗುತ್ತೆ, 5 km per hour ವಾಟರ್ ಬರ್ತಾ ಇದೆ. 5 km per hour ವಾಟರ್ ಹೊರಗಡೆ ಹೋಗ್ತಾ ಇದೆ. ಏನಾಗುತ್ತೆ, ವಾಟರ್ ಲೆವೆಲ್ ಇಟ್ ವಿಲ್ ಬಿ ಕಾನ್ಸ್ಟೆಂಟ್ ಅಲ್ಲ. ವಾಟರ್ ಲೆವೆಲ್ ಇಟ್ ವಿಲ್ ಬಿ ಕಾನ್ಸ್ಟೆಂಟ್. ಮೀನ್ಸ್ rate of forward reaction and the rate of backward reaction has been became equal. Now water which is coming with the 5 km per hour and the water which is going out from the 5 km per hour, it has become same. Means water level it will be constant. Water it will not be increased and water it will not be decrease. Now that state we call it as a equilibrium. ಅದನ್ನ ಏನಂತಾರೆ, equilibrium ಅಂತಾರೆ. Is it clear? Okay. Next, equilibrium ಅಲ್ಲಿ we are going to see irreversible process and the reversible process. Irreversible process ಅಂದ್ರೆ ಏನಂದ್ರೆ, the reaction proceeds with one direction only. Now irreversible reaction ಅಂದ್ರೆ ರಿಯಾಕ್ಷನ್ ಒನ್ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲೇ ಹೋಗುತ್ತೆ. ನಾವು ರಿಯಾಕ್ಟೆಂಟ್ಸ್ ಆಲ್ಮೋಸ್ಟ್ will complete into products. Reactants almost it will be complete into products. Reactants product ಅಲ್ಲಿ complete ಆಗುತ್ತೆ. Now the examples for the irreversible reaction ಏನಂದ್ರೆ, example for the irreversible reaction decomposition reactions. Decomposition reaction ಅಂದ್ರೆ KClO3 potassium chlorate now decompose to give KCl plus 3O2 gas. Now this is 2, this is 2. Now this is the example for the decomposition reaction. Okay, next combustion reaction ಅಂದ್ರೆ ಏನು, methane plus oxygen gives rise to CO2 plus H2 ಅಲ್ಲ. ನಾವು ಇಲ್ಲಿ ನೋಡಿ, ನಾವು ಕಾರ್ಬನ್ ಎಷ್ಟಿದೆ ರಿಯಾಕ್ಟೆಂಟ್ ಸೈಡು 1 ಅಲ್ಲ, ಪ್ರಾಡಕ್ಟ್ ಸೈಡು 1. ನಾವು ರಿಯಾಕ್ಟೆಂಟ್ ಸೈಡ್ ಎಷ್ಟು ಹೈಡ್ರೋಜನ್ಸ್ ಇದೆ 4 ಅಲ್ಲ, ನಾವು ಪ್ರಾಡಕ್ಟ್ ಸೈಡ್ ಎಷ್ಟು ಹೈಡ್ರೋಜನ್ಸ್ ಇದೆ 2 ಅಲ್ಲ. Now means to make it balance we have to multiply with the 2. Now the carbon has been balanced, hydrogen has been balanced. Now next after now combustion reaction balance ಮಾಡೋಕೆ ಫಸ್ಟ್ ನೀವು ಏನು ಮಾಡಬೇಕಂದ್ರೆ, ಫಸ್ಟ್ ಯು ಹ್ಯಾವ್ ಟು ಬ್ಯಾಲೆನ್ಸ್ ದ ಕಾರ್ಬನ್, ಆಮೇಲೆ ಆಕ್ಸಿಜನ್ ಆಮೇಲೆ ಹೈಡ್ರೋಜನ್ ಆಮೇಲೆ ಆಕ್ಸಿಜನ್ ಬ್ಯಾಲೆನ್ಸ್ ಮಾಡಿ. ನೆಕ್ಸ್ಟ್ ಇಲ್ಲಿ ನೋಡಿ, ಪ್ರಾಡಕ್ಟ್ ಸೈಡ್ ಎಷ್ಟು ಆಕ್ಸಿಜನ್ಸ್ ಇದೆ 4 ಅಲ್ಲ, ರಿಯಾಕ್ಟೆಂಟ್ ಸೈಡ್ ಎಷ್ಟು ಆಕ್ಸಿಜನ್ಸ್ ಇದೆ 2 ಅಲ್ಲ. To balance it we have to keep it with the 2. Now this is a combustion reaction. The decomposition reaction, this is a combustion reaction. Next acid base reaction, NaOH plus HCl gives rise to NaCl plus H2O. ನಾವು ಇದು ಯಾವುದು ರಿಯಾಕ್ಷನ್? ಆಸಿಡ್ ಬೇಸ್ ರಿಯಾಕ್ಷನ್. ಆಸಿಡ್ ಬೇಸ್ ರಿಯಾಕ್ಷನ್ ಎಲ್ಲಿಗೂ ಬರುತ್ತೆ? ಇರ್ರಿವರ್ಸಿಬಲ್ ಪ್ರಾಸೆಸ್ಗೂ ಬರುತ್ತೆ. ನೆಕ್ಸ್ಟ್ ಪ್ರಿಸಿಪಿಟೇಷನ್ ರಿಯಾಕ್ಷನ್. ಪ್ರಿಸಿಪಿಟೇಷನ್ ರಿಯಾಕ್ಷನ್ AgNO3 plus NaCl. AgNO3 plus NaCl gives rise to AgCl precipitate plus NaNO3. Is it clear? Now these are the examples for the irreversible process. Irreversible process on the direction alle hogutte. All the reactants will be almost, it will be converted into products. Reactants will be almost converted into products. Is it clear? Adano irreversible process. Next or reversible reaction. Now irreversible process or irreversible reaction. Illi nodi reversible reaction. Reversible reaction andre now here reaction proceeds with forward direction. Reaction proceed with forward direction and backward direction. Reaction proceed with forward direction and backward direction. Now reactants will not convert into products. It may attain equilibrium. Now examples for the irreversible reaction ಏನಂದ್ರೆ now PCl5 gas now gives rise to PCl3 gas plus Cl2 gas. Okay, next H2 gas plus I2 gas gives rise to 2HI gas. Okay, next N2 gas plus O2 gas gives rise to 2NO gas. Okay, now these are the examples for the reversible process. Irreversible process reversible process ki ಏನು ಡಿಫರೆನ್ಸ್ ಇದೆ ಅಂದ್ರೆ ಇಲ್ಲಿ ನೋಡಿ, ನಾವು ಈಗ ಒಂದು ಓಪನ್ ವೆಜಿಲ್ ತಗೊಂಡಿದ್ದೀರಂದ್ರೆ ನಾವು ಈ ಓಪನ್ ವೆಜಿಲ್ ಅಲ್ಲಿ ಕ್ಯಾಲ್ಸಿಯಂ ಕಾರ್ಬೋನೇಟ್ ಸಾಲಿಡ್ ಈಸ್ ಹೀಟ್ ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ? ಕ್ಯಾಲ್ಸಿಯಂ ಆಕ್ಸೈಡ್ ಪ್ಲಸ್ CO2 ಗ್ಯಾಸ್ ಅಲ್ಲ. ಮೀನ್ಸ್ ಈಗ ಈ ವೆಜಿಲ್ ಅಲ್ಲಿ ಕ್ಯಾಲ್ಸಿಯಂ ಕಾರ್ಬೋನೇಟ್ ತಗೊಂಡಿದ್ರಂದ್ರೆ ಹೀಟ್ ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ? ಕ್ಯಾಲ್ಸಿಯಂ ಆಕ್ಸೈಡ್ ಪ್ಲಸ್ CO2 ಅಲ್ಲ, ಈ ಗ್ಯಾಸ್ ಏನಾಗುತ್ತೆ? ಮೇಲೆ ಹೋಗುತ್ತೆ. ದಿಸ್ ಗ್ಯಾಸಿಯಸ್ ಪ್ರಾಡಕ್ಟ್ಸ್ ವಿಲ್ ಎಲಿಮಿನೇಟ್ ಫ್ರಮ್ ದ ವೆಜಿಲ್. ಈ ಗ್ಯಾಸಿಯಸ್ ಪ್ರಾಡಕ್ಟ್ ವೆಜಿಲ್ ಇಂದ ಮೇಲೆ ಹೋಗುತ್ತೆ. ಆಫ್ಟರ್ ದಟ್ ವಾಟ್ ಹ್ಯಾಪನ್? ನೌ ವೆನ್ ದೀಸ್ ಗ್ಯಾಸಿಯಸ್ ಪ್ರಾಡಕ್ಟ್ಸ್ ಹ್ಯಾಸ್ ಬೀನ್ ಎಲಿಮಿನೇಟೆಡ್ ಫ್ರಮ್ ದ ವೆಜಿಲ್, will this calcium oxide again it will be converted into calcium carbonate? See, this calcium oxide again recombines to give the calcium carbonate. Will it give? Illala. Means that's a reason now equilibrium to be established. For that one, what type of the vessel it should be happen? Now reversible reaction or reversible process will happen only in the closed container. Now irreversible process, most of the irreversible process will be takes place in the open vessel. Now most of the irreversible processes take place in the open vessel. For reversible processes takes place only in the which one? Closed vessel. Yakandre now here is nodi H2 gas plus I2 gas gives rise to 2HI gas. Now whatever the gaseous particles are there, gaseous molecules are there, or compounds are there, it will be in the closed vessel only. H2 combines to give the I2. H2 reacting with I2 gives rise to 2HI gas. Now the 2HI gas, it will be present in this closed container only. Again this 2HI will be converted into I2 and the H2. Means equilibrium to be established. Now there it should be a closed vessel. Is it clear? Next. Now physical equilibrium. And the chemical equilibrium. Physical equilibrium and the chemical equilibrium andre enandre, physical equilibrium andre molecular formula same, but its phase may be different. Phase may be different ಏನಂದ್ರೆ, ಈಗ H2O ಸಾಲಿಡ್ ತಗೊಂಡಿದ್ವಿ ಅಂದ್ರೆ H2O ಸಾಲಿಡ್ ಅಂದ್ರೆ ice. Now when it is melt, it will be converted into liquid. Means molecular formula of the H2O and the H2O liquid is same, but molecular formula of H2O is same, but its phase is different alla. Ice, it is in the solid. Liquid, it is in the water. Okay, ಅದನ್ನು that type of the equilibrium ಏನಂತಾರೆ, physical equilibrium ಅಂತಾರೆ. ಈಗ if you take chemical equilibrium ಅಂದ್ರೆ ಏನಂತಾರೆ ಅಂದ್ರೆ, chemical equilibrium ಅಂದ್ರೆ ಈಗ ನೀವು PCl5 ತಗೊಂಡಿದ್ದೀವಿ ಅಂದ್ರೆ ಇಲ್ಲಿ ನೋಡಿದೀವಲ್ಲ PCl5. now PCl5, it is converting into PCl3 gas and the Cl2 gas. Means its chemical formula is changing. That type of equilibrium ಏನಂತಾರೆ, chemical equilibrium ಅಂತಾರೆ. Is it clear? now physical equilibrium ಅಲ್ಲಿ we are having three types. ಒಂದು solid liquid equilibrium, ಒಂದು liquid gaseous equilibrium, ಒಂದು solid gaseous equilibrium. We are having the three types of the equilibrium. ಯಾವುದು? ಒಂದು solid liquid gaseous and the solid gaseous. now first we'll see solid liquid equilibrium. ಅಂದ್ರೆ ಇಲ್ಲಿ ನೋಡಿ, ಒಂದು ವೆಸೆಲ್ ತಗೊಂಡಿದ್ದೀನಿ. ಈಕ್ವಿಲಿಬ್ರಿಯಂ ವಿಲ್ ಎಸ್ಟಾಬ್ಲಿಷ್ ಓನ್ಲಿ ಇನ್ ದ ಕ್ಲೋಸ್ಡ್ ಕಂಟೈನರ್. ದಟ್ ಯು ಹ್ಯಾವ್ ಟು ರಿಮೆಂಬರ್. ಇದು ನೆನ್ಪಿಟ್ಕೋಬೇಕು. ಈಸ್ ಇಟ್ ಕ್ಲಿಯರ್? ಇಫ್ ದ ವೆಸೆಲ್ ಈಸ್ ಓಪನ್ ವೆಸೆಲ್, there is no equilibrium established. Is it clear? Equilibrium will establish only in the closed container. now here solid liquid equilibrium alli, now this is a water. now water mele ice. now this is ice. now this vessel is isolated. now inside the container, inside the vessel, now temperature is to 0 degree and the pressure is to 180. now e condition this condition I am keeping. ಇಲ್ಲಿ ನೋಡಿ, here this ice and the water is in equilibrium. ನಾನು why isolated ಅಂದ್ರೆ ಏನು? ಥರ್ಮೋಡೈನಮಿಕ್ಸ್ ಅಲ್ಲಿ ನಾನು ಹೇಳಿದನಲ್ಲ, ಐಸೋಲೇಟೆಡ್ ಸಿಸ್ಟಮ್. ಅಂದ್ರೆ no exchange of matter as well as energy ಅಲ್ಲ. no exchange of matter and the energy. that type of that one, it is called the isolated. ಯಾಕಂದ್ರೆ why we are maintaining the isolated system ಅಂದ್ರೆ because equilibrium may disturb. Equilibrium will disturb only with the temperature. This point is very, very important. Equilibrium will affect with temperature. now ಯಾಕಂದ್ರೆ ಹೊರಗಡೆ ಬೇರೆ ಬೇರೆ ಟೆಂಪರೇಚರ್ಸ್ ಇರುತ್ತಲ್ಲ, ಅದಕ್ಕೋಸ್ಕರನೇ we are maintaining the isolated system and inside the container 0 degree. means ಇದರಲ್ಲಿ H2O solid, now equilibrium with H2O ಲಿಕ್ವಿಡ್. ಅಂದರೆ ರೇಟ್ ಆಫ್ ಮೆಲ್ಟಿಂಗ್ is equal to rate of freezing. Rate of melting is equal to rate of freezing ಅಲ್ಲ. ನಾವು ಐಸ್ ಮತ್ತೆ ವಾಟರ್ ಎರಡು ಈಕ್ವಿಲಿಬ್ರಿಯಮ್ ಅಲ್ಲಿ ಇದೆ. ಇಸ್ ಇಟ್ ಕ್ಲಿಯರ್? ದಟ್ ವಿ ಕಾಲ್ ಇಟ್ ಆಸ್ ಅ solid liquid equilibrium. Equilibrium will affect with only the temperature. This you have to remember. Equilibrium will disturb only with the temperature. Now not to disturb the equilibrium, ಅದಕ್ಕೋಸ್ಕರನೇ ನಾವು ಐಸೋಲೇಟೆಡ್ ತಗೊಂಡಿದ್ವಿ. ಐಸೋಲೇಟೆಡ್ ಅಂದ್ರೆ it will not allow the exchange of heat, matter and the energy. Next, liquid gas equilibrium. ಲಿಕ್ವಿಡ್ ಗ್ಯಾಸ್ ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಅಂದ್ರೆ ಏನು? ಲಿಕ್ವಿಡ್ ಗ್ಯಾಸ್ ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಅಂದ್ರೆ ಸೇಮ್ ವಿಸಿಲ್. ಹಿಯರ್ ಸಮ್ ವಾಟರ್. ದಿಸ್ ಈಸ್ ಯಾವುದು? ದಿಸ್ ಈಸ್ ವೋಲಟೈಲ್ ಲಿಕ್ವಿಡ್. ವೋಲಟೈಲ್ ಲಿಕ್ವಿಡ್ ಅಂದ್ರೆ ಇಟ್ ವಿಲ್ ಬಿ ಎವಾಪರೇಟ್. ನಾವು ಇದರಲ್ಲಿ ಕಂಡೀಷನ್ಸ್ ಎಷ್ಟು? ಇನ್ಸೈಡ್ ದ ಕಂಟೈನರ್ ಟೆಂಪರೇಚರ್ ಎಷ್ಟು? 25 ಡಿಗ್ರಿ. ಇದನ್ನು ಐಸೋಲೇಟೆಡ್ ಸಿಸ್ಟಮ್, ಐಸೋಲೇಟೆಡ್ ಮಾಡಿದ್ದೇವೆ. ಯಾಕಂದ್ರೆ ಇಫ್ ಯು ಹ್ಯಾವ್ ನಾಟ್ ಮೇಂಟೈನ್ ದ ಐಸೋಲೇಟೆಡ್ ಮಾಡಿಲ್ಲ ಅಂದ್ರೆ ನಾವು ಹೊರಗಡೆ ಬೇರೆ ಟೆಂಪರೇಚರ್ ಇತ್ತಲ್ಲ, ನಾವು ಡ್ಯೂ ಟು ದಟ್ ಡಿಫರೆಂಟ್ ಟೆಂಪರೇಚರ್ ಈಕ್ವಿಲಿಬ್ರಿಯಮ್ ಡಿಸ್ಟರ್ಬ್. ಅದಕ್ಕೋಸ್ಕರನೇ ವಿ ಆರ್ ಮೇಕಿಂಗ್ ದಿಸ್ ಆಸ್ ಅ ಸಿಸ್ಟಮ್ ಆಸ್ ಅ ಐಸೋಲೇಟೆಡ್. ಓಕೆ, ಮೀನ್ಸ್ ಇದರಲ್ಲಿ H2O liquid is equilibrium with H2O gaseous. ಅಂದ್ರೆ rate of vaporization is equal to rate of condensation. Rate of evaporation is equal to rate of condensation. Now liquid gaseous equilibrium ಅಲ್ಲಿ rate of evaporation is equal to rate of condensation. Liquid is converting into gaseous, ಏನಂತಾರೆ? evaporation. Gas is converting into liquid, condensation. Is it clear? ನಾವು ಎರಡು ಈಕ್ವಿಲಿಬ್ರಿಯಂ ನಲ್ಲಿ ಇದೆ. ಎಷ್ಟು ಟೆಂಪರೇಚರ್ ಅಲ್ಲಿ? 25 ಡಿಗ್ರಿ ಟೆಂಪರೇಚರ್, ರೂಟ್ ಟೆಂಪರೇಚರ್ ಅಲ್ಲಿ. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ಸಾಲಿಡ್ ಗ್ಯಾಸಿಯಸ್ ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಅಂದ್ರೆ solid substance is directly converting into the liquid without going into the solid substance is directly converting into the gaseous without going into the liquid. Now here equilibrium attain only in volatile solids. Equilibrium will attain only in the volatile solids. What are the volatile solids? Examples ಯಾವುದು? First is solid iodine. Next, dry ice. Next, ammonium chloride. Next, camphor. Now these are the examples for the solid gaseous equilibrium. ಇಲ್ಲಿ ನೋಡಿ, now solid iodine directly it will be converted into the gaseous. ಅಂದ್ರೆ rate of sublimation is equal to rate of condensation. Okay, now solid gas equilibrium ಅಲ್ಲಿ rate of sublimation is equal to rate of condensation. Is it clear? Now ಇದರಲ್ಲಿ ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಅಲ್ಲಿ ಫಿಸಿಕಲ್ ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಅಲ್ಲಿ ಕೆಮಿಕಲ್ ಫಾರ್ಮುಲಾ ಸೇಮ್ ಇರುತ್ತೆ, ಬಟ್ ಫೇಸಸ್ ಆರ್ ಡಿಫರೆಂಟ್. different. Okay, means in that we have seen solid liquid, liquid gaseous, solid gaseous. Okay, next chemical equilibrium. Now, chemical equilibrium andre eno? Chemical equilibrium andre eno? Now, equilibrium involving in chemical changes. Equilibrium involving in the chemical changes. Illi nodi, N2 gas plus O2 gas gives rise to 2NO gas. ಇದರಲ್ಲಿ ನೋಡಿ ಈ ಎರಡು ಕೆಮಿಕಲ್ ಫಾರ್ಮುಲಾಸ್ ಬೇರೆ. Now that combines to give the 2NO gas. Now these two are undergoing the chemical change and establishing the equilibrium. That type of equilibrium ಏమంತಾರೆ? Chemical equilibrium. Chemical equilibrium. Next, PCl5 gas gives rise to Cl2 gas plus PCl3 gas. Okay, next, I2 gas, H2 gas plus I2 gas gives rise to 2HI gas. 2HI gas. See, ಈ ಎಲ್ಲ examples ಅಲ್ಲಿ now chemical formula is different. Chemical formula ಬೇರೆ. So that it is involving in the chemical reaction. ಈ ಎಲ್ಲ examples it is involving in the chemical reaction. ಅದಕ್ಕೋಸ್ಕರನೇ these are comes under the chemical equilibrium. Is it clear? Okay. Characteristics of the chemical equilibrium. Characteristics of the chemical equilibrium ಏನಂದ್ರೆ ಇಲ್ಲಿ ನೋಡಿ, equilibrium can only attain in the reversible process. Reaction is carried out in the closed container. Now starting ಅಲ್ಲಿ ನಾನು ಹೇಳಿದನಲ್ಲ, what I said equilibrium will establish only in the closed container. ಈಗ ಅದು closed container ಇಲ್ಲ ಅಂದ್ರೆ, if the container is not the closed container, open vessel ಅಂದ್ರೆ, this calcium carbonate ತಗೊಂಡಿದ್ರೆ ಹೀಟ್ ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ, ಕ್ಯಾಲ್ಸಿಯಂ ಆಕ್ಸೈಡ್ ಪ್ಲಸ್ CO2 gas ಅಲ್ಲ. Now this CO2 gas will be eliminated from the vessel. Now ಈಗ again this calcium oxide will not give the calcium carbonate ಅಲ್ಲ, calcium carbonate ಅಲ್ಲ, means the reaction is not reversible. The reaction is not reversible. ಈಗ if you have taken the closed vessel, now if you have taken the closed vessel ಏನಾಗುತ್ತೆ, ಈ ಎಲ್ಲ ಪ್ರಾಡಕ್ಟ್ಸ್ ಈ ವೆಸಲ್ ಅಲ್ಲೇ ಇರುತ್ತಲ್ಲ, ಈ ಎಲ್ಲ ಪ್ರಾಡಕ್ಟ್ಸ್ ವೆಸಲ್ ಅಲ್ಲೇ ಇರುತ್ತಲ್ಲ, ಮತ್ತೆ ಈ ಎರಡು ಪ್ರಾಡಕ್ಟ್ಸ್ ರಿಯಾಕ್ಟ್ ಮಾಡಿ ರಿಯಾಕ್ಟೆಂಟ್ ಬರುತ್ತೆ. Is it clear? For that reason only, that's the reason that process when these products again reacting to give the product, these products again reacting to give the reactants, now that process we call it as a reversible process. Now for that one ಏನಿರಬೇಕು, closed container ಇರಬೇಕಲ್ಲ, for that one closed container ಇರಬೇಕು. Next, equilibrium can attain from both sides. Equilibrium can attain from the both sides. ಅಂದ್ರೆ ಇಲ್ಲಿ ನೋಡಿ, PCl5 gas, now rate of forward reaction, ಇದು forward reaction, it gives rise to PCl3 gas plus Cl2 gas. Now again this PCl3 and the Cl2 combines to give the PCl5 gas, that is rate of backward reaction. ಅಂದ್ರೆ equilibrium can attain the forward direction, equilibrium can attain at the backward direction. Next, the rate of forward reaction decreases and that of backward reaction increases, and both became equal when the equilibrium is attained. ಇಲ್ಲಿ ನೋಡಿ, now PCl5 now rate of forward reaction, ಇದು rate of forward reaction. Now this is rate of backward reaction, gives rise to PCl3 gas plus Cl2 gas. Initial time t is equal to 0. Now 5 moles of PCl5 ನಾನು ತಗೊಂಡಿದ್ದಂದ್ರೆ, now PCl3 0, Cl2 0 ಅಲ್ಲ. Now at time t is equal to it has attained the equilibrium. At equilibrium, now from the 5 moles 2 moles has been, from the 5 moles 2.5 moles has been dissociated, and the 2.5 moles of the PCl3 and 2.5 moles of the Cl2 has been came. Now ಇಲ್ಲಿ ನೋಡಿ, next, draw the graph between rate versus time. Now Now at time t is equal to, at time t 0 is equal to PCl5 concentration how much? 5 alla, means rate of forward reaction at time t is equal to rate of forward reaction is decreasing. Now the rate of backward reaction is increasing alla, products is increasing, reactants is decreasing. Now at certain point it will join. Now this is a equilibrium. Now it will become constant. Now this is equilibrium, this point is equilibrium. Equilibrium alla, means here, now at equilibrium rates may be equal. At equilibrium what it may be equal? Rates may be equal but not the concentration. Now ಇದರಲ್ಲಿ ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಅಲ್ಲಿ ರೇಟ್ಸ್ ಈಕ್ವಲ್ ಆಗುತ್ತೆ, ಬಟ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಮೇ ಈಕ್ವಲ್ ಮೇ ನಾಟ್ ಬಿ ಈಕ್ವಲ್, ಮೇ ಈಕ್ವಲ್ ಮೇ ನಾಟ್ ಬಿ ಈಕ್ವಲ್. ಹೆಂಗಂದ್ರೆ ಇದು ಹೆಂಗೆ ನೋಡ್ಬೋದು. ನಾವು ಲೆಟ್ಸ್ ಸಿ the concentration of the reactant decreases. Now let's see, just now we have seen rate of the forward reaction is decreasing, andre reactants concentration decrease ಆಗ್ತಾ ಇಲ್ಲಲ್ಲ, it is decreasing, right? Now products concentration is increasing. ಇಲ್ಲಿ ನೋಡಿ, ನಾವು ಮುಂಚೆ ಫಸ್ಟ್ ಸ್ಟಾರ್ಟಿಂಗ್ it is 0 concentration. Now at the time t, now products concentration increasing ಇಲ್ಲ. Now both became constant when equilibrium is attained. When both the concentration of the reactant and the products has become constant, then only we say it as a equilibrium. Now let's see, ille nodi ide same example. PCl5 gas gives rise to PCl3 gas plus Cl2 gas. Now ee experiment 3 experiments ಮಾಡ್ತಾ ಇದ್ದೆ ನಾನು, 3 experiments ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಫಸ್ಟ್ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಏನಂದ್ರೆ ಟೈಮ್ ಟಿ ಈಸ್ ಈಕ್ವಲ್ ಟು 0 5 mole. now this is 0 0. now ಈ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಅಲ್ಲಿ ನನಗೆ ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಎಟ್ 25 5 moles ಇಂದ, from the 5 mole only 25%, only the 25% of the reactant has been converted into products. Reactant has been converted into the products. Then equilibrium has been attained. When the 25% of the reactant, 25% of the reactant has been converted into products, that time only we got the equilibrium. Now T 25%, first experiment alli at T 25% only, from the 5 only 1 mole product alli convert ಆಯಿತು. ಆ ಟೈಮಲ್ಲಿ equilibrium it came. Equilibrium has been attained when 25% has been converted into products. 1 ಮತ್ತೆ 1. Now let's see the graph for this one. Now for this experiment ge graph, concentration versus time, concentration versus time. ಇಲ್ಲಿ ನೋಡಿ, now at a time t is equal to 0, now PCl5 concentration is to 5. now at time t equilibrium it has been reached. Now at equilibrium, now remaining moles of the PCl5 is 4 alla. Now this is 4. Now concentration of the PCl5 has been became constant. Next at a time t is equal to, now PCl3 and the Cl2 products concentration has been increased to the 1 alla. Now this is 1. Now this is 4. Now after that it became constant. Now this, when these concentration reactants ಮತ್ತೆ products concentration ನಾವು ಯಾವಾಗ ಕಾನ್ಸ್ಟೆಂಟ್ ಆಗುತ್ತೋ, that we say it as a equilibrium. now this is a equilibrium, it is a equilibrium. ಇಲ್ಲಿ ನೋಡಿ, rate of forward reaction ಮತ್ತೆ rate of backward reaction it has been not equal. here concentration when reactants ಮತ್ತೆ products concentration constant ಆಗುತ್ತೋ ಆವಾಗನೇ equilibrium ಬರುತ್ತೆ. is it clear? that time only the equilibrium will be attained. next experiment ನಾನು ನೆಕ್ಸ್ಟ್ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಮಾಡಿದ್ದೀನಿ. ನಾವು ಈ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಅಲ್ಲಿ this time equilibrium after 75%. now when the reactant 75% has been converted into products, ಆವಾಗನೇ ನನಗೆ equilibrium ಬರುತ್ತೆ. equilibrium has been came when the 75% of the reactant concentration has been converted into products. ಅಂದ್ರೆ from the 5 mole in the 3 mole has been converted into the products. now remaining ಎಷ್ಟು mole ಇದೆ ರಿಯಾಕ್ಟೆಂಟ್ ಸೈಡ್ ಅಲ್ಲಿ 2 ಅಲ್ಲ. ನೌ ಫಾರ್ ದಿಸ್ ಒನ್ ವಿ ಡ್ರಾ ಎ ಗ್ರಾಫ್. ಕಾನ್ಸಂಟ್ರೇಷನ್ ವರ್ಸಸ್ ಟೈಮ್, ಕಾನ್ಸಂಟ್ರೇಷನ್ ವರ್ಸಸ್ ಟೈಮ್. ಇಲ್ಲಿ ನೋಡಿ ನಾವು PCl5 ಅಲ್ಲ, ನಾವು PCl5 ಸ್ಟಾರ್ಟಿಂಗ್ ಅಲ್ಲಿ 5 ಅಲ್ಲ. ನಾವು with the rate, with the time at equilibrium, it has been decreased up to 2 and it became constant. It became constant. Now products, it has been increased up to the 3. It has been increased up to the 3 and after that it became constant and it became constant. Here the rates has been became equal. Rate of forward reaction, rate of backward reaction has been became equal. Now but concentration has been equilibrium. Equilibrium has been attained here. For the here rate of forward reaction and rate of backward reaction has been became equal. But equilibrium has been attained here. ಯಾಕಂದ್ರೆ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಆಫ್ ರಿಯಾಕ್ಟೆಂಟ್ಸ್ ಮತ್ತೆ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಆಫ್ ದ ಪ್ರಾಡಕ್ಟ್ಸ್ has became constant ಅಲ್ಲ. Then the equilibrium has been attained. Here the equilibrium has been attained. Here the equilibrium has been attained. Is it clear? Now at equilibrium, rate of forward reaction and the rate of backward reaction may be equal. But concentration, when it will become the equilibrium, when the equilibrium will be attained for the concentration, when the concentration of the reactant and the product should become constant, then only the equilibrium barutte. Is it clear? Okay, next law of mass action. Now law of mass action, this is very important. Now ಎಲ್ಲ ಚಾಪ್ಟರ್ law of mass action ಮೇಲೆನೆ ಹೋಗುತ್ತೆ. It will be proceed on the law of mass action only. See, law of mass action ಅಂದ್ರೆ ಏನು? At particular temperature, rate of chemical reaction is directly proportional to product of their active mass. Active mass raised to the power of their stoichiometric coefficient. Active mass andre ಏನಂದ್ರೆ active mass, this active mass will play very important role. Now this square bracket represents the active mass or activity mass. Active mass, the square bracket represent the active mass. Active mass ಏನಂದ್ರೆ ನಾನು ಡೀಟೇಲಿ ಕ್ಲಿಯರ್ಲಿ ನಾನು ಹೇಳ್ತೀನಿ ನಿಮಗೆ. ಸಿ ಫಸ್ಟ್ chemical reaction. Now let's one chemical reaction is happening. Now this is a chemical reaction gives rise to product. Now for this one write the rate expression. Rate expression ಹೆಂಗ್ ಬರ್ಬೋದು ಅಂದ್ರೆ rate R is directly proportional to, now R is directly proportional to activity mass. ಈ ಸ್ಕ್ವೇರ್ ಬ್ರಾಕೆಟ್ ಏನಂತಾರೆ activity mass. Activity mass and ಏನಂತಾರೆ ನಾನು ಡೀಟೇಲಿ ನಾನು ಹೇಳ್ತೀನಿ. Now activity mass of A raised to the power its stoichiometric coefficient. Raised to the power its stoichiometric coefficient is 2. Now ಇಲ್ಲಿ activity mass of B raised to the power its stoichiometric coefficient is 3. Raised to the power its stoichiometric coefficient is 3. Okay, now by removing this proportionality constant n barutte is equal to K concentration of A and the concentration of B. Okay, now this is the rate expression. This is the rate expression and this is the law of mass action. ಇದನ್ನ ಏನಂತಾರೆ law of mass action. Law of mass action is equal to directly proportional to the activity mass of the A raised to the power its stoichiometric coefficient. Now this K is the rate constant. This is a rate constant. This is a rate constant. Now ಇಲ್ಲಿ ನೋಡಿ activity mass. Now activity mass or activity coefficient ಎರಡೂ ಸೇಮ್. activity mass or activity coefficient. Activity mass or we can represent with the A. Now for solution, if the chemical reaction is in the solution, for that one chemical reaction, now activity for solution, activity coefficient is expressed in the form of molar concentration. Molar concentration ಅಂದ್ರೆ ಏನು? Concentration C is equal to concentration ಅಂದ್ರೆ molarity. Molarity formula ಏನು? Number of moles by volume in liter ಅಲ್ಲ. Means activity coefficient is expressed in the form of concentration. Concentration ಅಂದ್ರೆ number of moles by volume in liter. Molarity ಅಲ್ಲ. Other name of the concentration, molarity. Molarity is equal to number of moles by volume in liter. For the solution, if the chemical reaction is a solution, if the chemical reaction is a solution, ಅದು chemical reaction solution ಅಲ್ಲಿ ಇದೆ ಅಂದ್ರೆ ಅದು activity mass ಹೆಂಗ್ ಬರಬಹುದು? in the terms of molar concentration, in the terms of or in the form of molar concentration. For gaseous, if the chemical reaction is in the form of a gaseous, ಈಗ ಆ chemical reaction gaseous ನಲ್ಲಿ ಇದೆ ಅಂದ್ರೆ now activity coefficient or activity mass is expressed in the form of partial pressure. ಈಗ that chemical reaction, if it is in the form of a gaseous, now that activity mass ఏ ತರನೋ ಬರಬಹುದು in the form of partial pressure. Is it clear? This is for the gaseous. For pure solids and pure liquids, now for pure solids and the pure liquids, activity coefficient will be equal to 1. ಹೆಂಗಂದ್ರೆ ನಾವು ಯಾಕಂದ್ರೆ ಇಲ್ಲಿ ನೋಡಿ, ನಾವು ಹಿಯರ್ activity ಅಂದ್ರೆ ಏನು? activity A is equal to concentration by volume ಅಲ್ಲ. now number of moles formula ಏನು? mass by molecular weight ಅಲ್ಲ. no mass by volume into molecular weight ಅಂದ್ರೆ mass by volume ಏನು? density by molecular weight ಅಲ್ಲ. density by molecular weight means activity is directly proportional to the density, right? Activity is directly proportional to the density, right? Activity is directly proportional to the density. now ಈಗ ಒಂದು ಸಾಲಿಡ್ ಸಬ್ಸ್ಟೆನ್ಸ್ ತಗೊಂಡಿದ್ದೀನಂದ್ರೆ ಕ್ಯಾಲ್ಸಿಯಂ ಕಾರ್ಬೋನೇಟ್ ಸಾಲಿಡ್. ಈಗ ಈ ಕ್ಯಾಲ್ಸಿಯಂ ಕಾರ್ಬೋನೇಟ್ ಸಾಲಿಡ್ ನಾವು when it is a reaction is happening, ಒಂದು ರಿಯಾಕ್ಷನ್ ನಡೀತಾ ಇದೆ ಅಂದ್ರೆ ನಾವು 100 grams ಆಫ್ ಕ್ಯಾಲ್ಸಿಯಂ ಕಾರ್ಬೋನೇಟ್ ನಾನು ತಗೊಂಡಿದ್ದೀನಂದ್ರೆ 100 grams ಆಫ್ ಕ್ಯಾಲ್ಸಿಯಂ ಕಾರ್ಬೋನೇಟ್ ಅಲ್ಲಿ ನಾವು 30 gram of calcium carbonate has been converted into product. 30 gram ಅಂದ್ರೆ ಇಲ್ಲಿ ನೋಡಿ, ಆ ಪ್ಯೂರ್ ಸಾಲಿಡ್ ಅಲ್ಲಿ 30 gram 100 gram ಇಲ್ಲ, 100 gram ಇಂದ 30 gram has been converted into the product. ಅಂದ್ರೆ 100 gram ಇಂದ 30 gram has been converted into the product ಅಂದ್ರೆ the same 30 ml ಡಿಗ್ರೀಸ್ ಆಗುತ್ತೆ. ಈಗ 30 gram ಪ್ರಾಡಕ್ಟ್ ಅಲ್ಲಿ ಕನ್ವರ್ಟ್ ಆಗಿದೆ ಅಂದ್ರೆ ಸೇಮ್ 30 ml ಆಫ್ ವ್ಯಾಲ್ಯೂಮ್ ಡಿಗ್ರೀಸ್ ಆಗುತ್ತೆ. ಈಗ 40 has been converted into product ಅಂದ್ರೆ 40 ml ಆಫ್ ವ್ಯಾಲ್ಯೂಮ್ ಆಲ್ಸೋ ಡಿಕ್ರೀಸ್. ಅಂದ್ರೆ how much gram of reactant has been converted into the product, at the same proportion the volume is also decreasing. 20 if it is converted into product, 20 ml of the volume is decreasing. Andre means density is constant, right? For the activity coefficient density is constant alla. Means instead of taking a constant for our mathematical calculation purpose, activity we are taking it as a 1. Is it clear? For pure solids and the pure liquids, activity coefficient we are taking it as a 1. Means Here 100 grams, 20 gram has been converting, 20 ml has been decreasing. 20 gram has been decreased as the same proportion 20 gram of the volume is also decreasing. Andre mass by volume density alla means density is constant. So adugoskarane instead of taking constant for our mathematical calculation purpose, we are taking it as a 1. Okay. Now for a solution, if the chemical reaction is expressed in the solution, we are taking it in the solution, we are taking it in the form of molar concentration. If the chemical reaction is expressed in the gaseous, we are taking in the form of a partial pressure P. Is it clear? Now for the pure solids and the pure liquids, activity mass A will be equal to 1. Okay. Next. Now determination of the equilibrium constant. Equilibrium constant ಹೆಂಗ್ find out ಮಾಡಬಹುದು? See, for a reversible reaction, ಒಂದು reaction ಕೊಟ್ಟಿದ್ರು. Now this is coefficient A and this is coefficient M1, this is coefficient M2, coefficient N1 and the coefficient N2. ಇದರಲ್ಲಿ ನೋಡಿ, now first forward reaction, ಇದು forward reaction ಅಲ್ಲ. Now this is backward reaction ಅಲ್ಲ. Now first forward reaction ಬನ್ನಿ. Forward reaction. Now forward reaction ಏನು? M1A1 plus M2A2 gives rise to N1B1 plus N2B2 so on. Now ಇದರಲ್ಲಿಂದು so on. Now for this reaction, for the rate of forward reaction ಗೆ, ಇದು forward reaction ಅಲ್ಲ. ಈ forward reaction ಗೆ apply the law of mass action. Apply law of mass action. Apply the law of mass action. Law of mass action ಅಂದ್ರೆ ಏನು? Rate is directly proportional to the activity. Rate is directly proportional to the activity coefficient or activity mass of A1. Activity is represented as A ala. Activity mass of A1 raised to the power its stoichiometric coefficient ala into product activity mass of A2 raised to the power M2. Now if you remove this proportionality constant, rate of forward reaction ala. Now rate of forward R is equal to, now ಒಂದು ಕಾನ್ಸ್ಟೆಂಟ್ ಬರುತ್ತೆ. This is writing for the rate of forward reaction ಅಲ್ಲ. So rate of forward is equal to activity coefficient or activity mass of A1 to M1 into activity coefficient or activity mass of A2 and the M2 so on. Now this is for the forward reaction. No. For a backward reaction. Next is backward reaction. Backward reaction ಅಂದ್ರೆ ಏನು? A2 N1B1 plus N2B2 gives rise to M1A1 plus M2A2 ಅಲ್ಲ. Means N1B1 plus N2B2 gives rise to M1A1 plus M2A2 so on. Now for this also apply the law of mass action. R is directly proportional to activity of B1 raised to the power N1. Now activity of B2 raised to the power N2. Now if you remove the proportionality constant, R is equal to ಒಂದು ಕಾನ್ಸ್ಟೆಂಟ್ ಬರುತ್ತೆ KB. Now A B1 raised to the power N1 into A B2 raised to the power N2. Now this is the equation number 1. Now this is the equation number 2. This is the equation number 1 and this is the equation number 2. Next. Now at equilibrium. Equilibrium ಅಂದ್ರೆ ಏನು? Rate of forward reaction is equal to rate of backward reaction ಅಲ್ಲ. Rate of forward reaction is equal to rate of backward reaction. Now this is rate of forward reaction Now this is rate of backward reaction, right? Now rate of forward reaction ಏನಿದೆ? Rate of forward reaction ಏನಿದೆ? Kf activity of A1 raised to the power m1 into activity coefficient A2 raised to the power m2 is equal to, now Kb, now activity coefficient of B1 raised to the power n1 into activity coefficient B2 raised to the power n2 ಅಲ್ಲ, so on. Now if you bring Kb to the left hand side and this entire terms to the right hand side, ಏನಾಗುತ್ತೆ? Kf by Kb is equal to A raised to the power n1 activity coefficient B2 raised to the power n2 so on by A raised to the power m1 into A raised to the power m2 so on. Now here Ka is equal to rate of forward reaction by rate of backward reaction. Here K andre ಏನಂದ್ರೆ equilibrium constant in terms of activity, activity mass, in terms of activity mass. Here Ka andre in terms of activity mass. Now activity mass ಈಗ we have ನೋಡಿದೀವಲ್ಲ, activity mass for solution ಗೆ concentration, activity mass for the gaseous ಗೆ partial pressure. ಅಂದ್ರೆ if it is a solution, if the reaction is solution, if the reaction is in the solution form, now in the place of Kf by Kb ಏನು ಬರಬಹುದು? K ಅಲ್ಲ. Now if Kc, if it is a solution, now if it is a solution, now in the form of activity in the form of activity coefficient or activity mass can be expressed in the form of concentration alla, means in the place of A we are going to write C, now concentration alla, activity mass in the form will be expressed in the form of concentration alla, in the place of A, now activity mass in the form of concentration raised to the power n1 and concentration raised to the power n2 so on by concentration raised to the power m1 into concentration raised to the power m2 so on. Now if it is a solution, if it is a gaseous, now if it is a gaseous activity mass edara barbodu Kp alla, means in the form of partial pressure alla, means in the place of A Kp is equal to in the place of A partial pressure of B n1 into partial pressure of B2 n2 by partial pressure of A m1 into partial pressure of A2 m2 so on. Means activity coefficient if it is in the form of solution, now equilibrium constant edara baribodu in the form of concentration. ಈಗ if the reaction it is in the form of gaseous, equilibrium constant edara baribodu in the form of Kp, is it clear? Okay. Relationship between the Kp and the Kc, now we'll see. Now for a gas phase reaction, reactants at the particular temperature, gas phase reaction ಅಂದ್ರೆ ಇಲ್ಲಿ ನೋಡಿ m1a1 plus m2a2 gives rise to now n1b1 plus n2b2 so on. Now e reaction it is in the form of gas phase, gas phase. Now e reaction, it is in the form of gas phase. If this reaction is in the form of a gas phase, now gas phase equilibrium constant ఏ తరను బరిಬೋದು equilibrium constant ಹೆಂಗ್ ಬರಿಬೋದು in the terms of concentration or in the terms of partial pressure. ಈಗ already they have given e reaction, it is in the form of a gaseous phase. ಅಂದ್ರೆ equilibrium constant we have to express in the terms of ఏ ತರ we have to express in the terms of gaseous phase. ಅಂದ್ರೆ kp is equal to partial pressure of b1 raised to the power its stoichiometric coefficient n1 into partial pressure b2 raised to the power its stoichiometric coefficient so on by, now here partial pressure a1 raised to the power m1 into partial pressure a2 raised to the power m2 so on. Now it is in the form of kp. Now for an ideal gas equation ಏನು pv is equal to nRT ಅಲ್ಲ, pv is equal to nRT. now take the v to the right hand side, ಏನು ಬರುತ್ತೆ p is equal to n by v RT ಅಲ್ಲ. now concentration ಅಂದ್ರೆ ಏನು molarity ಅಲ್ಲ, molarity ಫಾರ್ಮುಲಾ ಏನು n by v ಅಲ್ಲ. now concentration means it is expressed, concentration no in the form of square bracket also we can express it, right? Square bracket also we can express, right? now in the form of n by v, now ಈ ತರನು ಬರಬಹುದಲ್ಲ, p is equal to concentration into RT. now whatever the p value it is there, now whatever the p value we are having, substitute in this equation 1, substitute in the equation 1. now when we substitute in the equation 1, now what we'll get, now p is equal to concentration RT, ಅಲ್ಲ. now kp is equal to now in the form of, in the place of p we are writing concentration RT ಅಂದ್ರೆ ಇಲ್ಲಿ ನೋಡಿ, now concentration of b1 RT raised to the power n1, next now concentration of b2 RT raised to the power n2 so on. next concentration of a1 into RT raised to the power m1. now concentration of a2 into RT into raised to the power m2 so on. okay, now here kp is equal to now separate the RT, concentration of b1 raised to the power n1, concentration of b2 raised to the power n2. now separate the RT raised to the power n1 plus n2. okay, here now concentration of a1 raised to the power m1, concentration of a2 raised to the power m2. now separate the RT m1 plus m2. now RT n1 plus n2, RT m1 plus m2. now we can express in this form, kp is equal to concentration of n1, now concentration of b2 n2, now concentration of m1, the concentration of m2, now RT into RT can we write n1 plus n2 minus m1 plus m2 ಅಲ್ಲ, means here these are the stoichiometric coefficients of the gaseous products ಅಲ್ಲ, gaseous reactants and products ಅಲ್ಲ. means here you see this one, it is in the form of Kc ಅಲ್ಲ. now Kc is what we are having, Kc is equal to concentration of B1 raised to the power N1, concentration B2 raised to the power N2, concentration A1 raised to the power M1, concentration A2 raised to the power M2 alla. Now it is in the form of Kc, right? It is in the form of Kc alla. It is in the form of Kc alla. Can I write like this? Now Kp is equal to Kc RT delta Ng. Delta Ng andre, now this is here delta Ng. Here delta Ng. Delta Ng is equal to number of moles of gaseous products, minus number of moles of gaseous reactants. Number of moles of gaseous product and the number of moles of gaseous reactant. So this is the number of moles of gaseous product. Remember the relationship between the Kp and Kc is equal to Kp is equal to Kc RT delta Ng. Kp is equal to Kc RT delta Ng. Now this is the relationship between the Kp is equal to Kc RT del Ng. Delta Ng, you know, number of moles of gaseous products minus number of moles of the gaseous reactant. Number of moles of the gaseous product and the number of moles of the gaseous reactant. Is it clear? Next. Now we'll see the now ಎರಡು ಮೂರು questions ನೋಡೋಣ. The whatever the concept we have studied ಆಮೇಲೆ whatever the concept we have studied, now on that we are going to see some questions. Now ಇಲ್ಲಿ ನೋಡಿ, for the system 3a plus 2b gives rise to C, the expression for the equilibrium constant. Now here equilibrium constant, here they are asking for this reaction, this reaction is in the form of solution. This reaction is in the form of the solution. For that one they are asking the equilibrium constant. Equilibrium constant for the solution, equilibrium constant for the reaction. Now how we can write? Equilibrium constant for a solution. Now if the expression is in the form of a solution, now we can express equilibrium, you can express in the form of concentration alla, we can express in the form of concentration. Now see here, equilibrium is equal to products by reactants alla, concentration of products by concentration of reactants, right? Concentration of products by concentration of reactants. Now there we are having equilibrium constant K is equal to concentration of products by concentration of reactant raised to the power its stoichiometric coefficient into concentration of B raised to the power its stoichiometric coefficient 2. Now this is the answer. Now match the following. Now 3a, it is not the answer. Now option number 2 is correct. Option number 2 is correct. Is it clear? Okay, option number 2 is correct for this question. Next. Next question ನೋಡೋಣ. ಈ ಕ್ವಶನ್ ಅಲ್ಲಿ ಏನ್ ಕೇಳ್ತಾ ಇದ್ರು? For a reversible reaction, rate constant for forward and backward reactions are 2.38 into 10 to the power minus 4 and 8.15 into 10 to the power minus 5 respectively. The equilibrium constant for the reaction is. Now at equilibrium, you know, rate of forward reaction and the rate of backward reaction is equal, right? Rate of forward reaction and the rate of backward reaction is equal. Andre equilibrium constant kelta idralla, at equilibrium Kc is equal to rate of forward reaction by rate of backward reaction. Rate of forward reaction Kc is equal to, at equilibrium constant is equal to rate of forward reaction by rate of backward reaction alla. ನಾನು ಡೆರಿವೇಶನ್ ಮಾಡಿದ್ದೀನಿ. ಈಗ ನಿಮಗೆ ಡೌಟ್ ಇದೆಯಾ ಅಂದರೆ ಒಂದ್ಸರಿ ಆ ಡೆರಿವೇಶನ್ ನೋಡ್ಬೋದು. ಕ್ಲಿಯರ್? ನಾವು ರೇಟ್ ಆಫ್ ಫಾರ್ವರ್ಡ್ ರಿಯಾಕ್ಷನ್ ಎಷ್ಟು? KF is equal to 2.38 into 10 to the power minus 4. Now rate of backward reaction is to 8.15 into 10 to the power minus 5. Clear? Now rate of forward reaction is equal to 2.38 into 10 to the power minus 4. Now rate of backward reaction 8.15 into 10 to the power minus 5. ಈಗ ನಾವು ನೀವು ಸಾಲ್ವ್ ಮಾಡಿ ನಾವು ವಾಟ್ ಈಸ್ ದ ಆನ್ಸರ್ ಅಂತ ಕಾಮೆಂಟ್ ಬಾಕ್ಸಲ್ಲಿ ಕಾಮೆಂಟ್ ಮಾಡಿ ನಾನು ನೋಡ್ತೀನಿ. ಓಕೆ, ಕ್ಲಿಯರ್? ನಾವು ದಿಸ್ ಈಸ್ ದ ಪ್ರಾಸೆಸ್. ನಾವು ಯು ಕ್ಯಾನ್ ಕಾಮೆಂಟ್ ದ ಆನ್ಸರ್ ಇನ್ ದ ಕಾಮೆಂಟ್ ಬಾಕ್ಸ್. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ಕ್ವಶನ್ ನೋಡೋಣ. ನೆಕ್ಸ್ಟ್ ಕ್ವಶನ್ ಯಾವುದು? ನಾವು in which of the following equilibrium Kp is equal to not, Kp is not equal to the Kc ಅಂತ ಕೇಳ್ತಾ ಇದ್ರು. ಓಕೆ, ನಾವು ರಿಲೇಶನ್ಶಿಪ್ ಬಿಟ್ವೀನ್ ದ Kp ಅಂಡ್ ದ Kc ನೋಡಿದೀವಲ್ಲ, ರಿಲೇಶನ್ಶಿಪ್ ಬಿಟ್ವೀನ್ ದ Kp ಅಂಡ್ ದ Kc ನೋಡಿದಿಲ್ಲ. Kp Kc ರಿಲೇಷನ್ ಏನು? Kp is equal to KCRT del Ng. Kp is equal to Kc into RT del Ng or delta Ng. Delta Ng ಅಂದ್ರೆ ಏನು? Number of moles of gaseous products, number of moles of gaseous products minus number of moles of gaseous reactants ಅಲ್ಲ, number of moles of gaseous products minus number of moles of gaseous reactants ಅಲ್ಲ. ಇಲ್ಲಿ ನೋಡಿ ನಿಂಗ್ಸ್, here del Ng will play the important role. Del Ng will play the important role. See here how many number of moles of gaseous products ಇದೆ. Now here you find out the del Ng for this one, del Ng for this one. Now del Ng for this one will be, now product side ಎಷ್ಟು gaseous ಮೋಲ್ಸ್ ಇದೆ, ಎಷ್ಟು ಗ್ಯಾಸಿಯಸ್ ಪ್ರಾಡಕ್ಟ್ಸ್ ಇದೆ, ಎಷ್ಟು ಮೋಲ್ಸ್ ಆಫ್ ಗ್ಯಾಸಿಯಸ್ ಪ್ರಾಡಕ್ಟ್ಸ್ ಇದೆ, ಎರಡು ಅಲ್ಲ, ಮೈನಸ್ ರಿಯಾಕ್ಟೆಂಟ್ ಸೈಡ್ ಎಷ್ಟು 2 is equal to 0. del Ng something raised to the power 0, something raised to the power 0 will be equal to 1. For this one Kp will be equal to Kc. Now so this option is wrong. Now next ಇಲ್ಲಿ ನೋಡಿ, ಈ ಆಪ್ಷನ್ ಅಲ್ಲಿ ಫಸ್ಟ್ ಫೈಂಡ್ ಔಟ್ ದ del Ng. Now ಇದರಲ್ಲಿ ಎರಡು, for this side also 2 moles of gaseous products and 2 moles of gaseous reactants. Del Ng will be 0, same. Here the something raised to the power 0 will be equal to 1. For this also Kp will be equal to Kc. So this option is also wrong. Now ಇಲ್ಲಿ ನೋಡಿ, for this also find out the del Ng. Del Ng is equal to, ಇದರಲ್ಲಿ ಎಷ್ಟು gaseous products ಇದೆ 2, ಇದರಲ್ಲಿ ಎಷ್ಟು gaseous products ಇದೆ, gaseous reactant ಇದೆ 2, so same. ಇದರಲ್ಲಿ also Kp is equal to Kc. Now ಇಲ್ಲಿ ನೋಡಿ, now for this option ಗೆ ಏನು, here del Ng will be equal to 2 minus 1 is equal to 1. ಯಾಕಂದ್ರೆ ಇಲ್ಲಿ this is not the gaseous reactant, ಇದು ಯಾವುದು solid. del Ng will be applicable only for the number of moles of gaseous products and the number of moles of gaseous reactant. ಇಲ್ಲಿ ಏನು ಕೊಟ್ಟಿದ್ರು, solid ಗೆ del Ng it will not be applicable. ಯಾಕಂದ್ರೆ this is constant. Activity mass for the pure solids and pure liquids will be 1 ಅಲ್ಲ, so this is constant. So ಅದಕ್ಕೋಸ್ಕರನೇ this is 1, means something raised to the power 1 will be equal to something, it will be get right, means Kp is not equal to Kc. So option number 4 is correct. Option number 4 is correct. Okay, by this we have ended our ಈಕ್ವಿಲಿಬ್ರಿಯಮ್ ಅಲ್ಲಿ. ಇನ್ ದಟ್ ಈಕ್ವಿಲಿಬ್ರಿಯಮ್ ಅಲ್ಲಿ, ಕೆಮಿಕಲ್ ಈಕ್ವಿಲಿಬ್ರಿಯಮ್ ಅಲ್ಲಿ ಫಸ್ಟ್ ಲೆಕ್ಚರ್ ನಂಬರ್ 1 ಮುಗೀತು. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ಈಗ ಈ ಲೆಕ್ಚರಲ್ಲಿ ನಿಮಗೆ ಏನಾದರೂ ಡೌಟ್ಸ್ ಇದೆಯಾ ಅಂದರೆ ಕಾಮೆಂಟ್ಸ್ ಬಾಕ್ಸಲ್ಲಿ ಕಾಮೆಂಟ್ ಮಾಡಿ, ನಾನು ಅಲ್ಲಿ ನೋಡಿ ನಿಮಗೆ ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸಲ್ಲಿ ವಾಟ್ ಎವರ್ ದ ಡೌಟ್ಸ್ ಯು ಆರ್ ಹ್ಯಾವಿಂಗ್, ಆ ಡೌಟ್ಸ್ನು ನಾನು ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸಲ್ಲಿ ನಿಮಗೆ ಕ್ಲಿಯರ್ ಮಾಡ್ತೀನಿ. ಓಕೆ, ನೌ by this I hope you have cleared the concepts. If you are having any doubts, you can comment in the comment box. See you, bye bye, and see you in the next video. Okay.